This is the homework on page 382 and 386. My numbers here are a bit wrong, so they're exactly one off, so you can kind of look at it from there. Okay, so we're going to name and write the formula of the conjugate base of each molecule or ion. So we're looking here for the conjugate base. So all these species have to be acids because acids have conjugate bases, right? So an acid we know is donating an H plus or a proton. So after it has donated the proton, the conjugate base is going to be the chloride ion, Cl minus. So this was already a negative charge. So we're going to split up the negative charge again. So the conjugate base here is going to be CO3 2 minus. It's 2 minus because it already had a negative charge and it lost a positive charge. So if you lose a positive charge, you become more negative. So it's 2 minus. H2SO4, again, it's losing a proton. So there's one H left, SO4 minus, because it's lost that one positive charge, it gets a negative charge. N2H5 plus. So let's remove an H plus from here, and you're left with N2H4. This positive has gone away along with one of the protons, so this is the conjugate base. So hopefully that was straightforward. Formula for the conjugate acid. So if we're looking for the conjugate acid, that means these guys are all bases. That means they're acting as hydrogen, or just keep saying hydrogen. I mean proton acceptors. So the H plus is going to come in and attach itself to the NO3 minus, so it's going to be HNO3, and the plus and minus basically cancel to give you no charge in the end. H plus is coming in, which leaves me with an HOH. Again, the minus plus get canceled, which is basically water, right? That's H2O. H plus coming in, we left with an H3O with a plus charge because there was one plus here. And again, H plus coming in, we have H2CO3. The minus and the plus cancel out to give you a neutral molecule. Identify the conjugate acid-base pairs in each reaction. So here, sorry about that. It probably isn't too hard to identify the pair. We know that HS is going to go with H2S and this is going to go with that. It's just which is acting as an acid and which is acting as a base at this given time. It is also not too difficult, hopefully. So we see here that the HS is becoming an H2S. So this S minus over here, this negative charge, is accepting the proton. So if it's accepting a proton, it's acting as a base. And we'll see that because the negative is becoming a 0, right? So it has accepted a positive charge from the proton. So this is the base in conjugate acid. Therefore, in this case, water is acting as an acid and OH minus is a conjugate base because water has given away that proton, one of its protons, to this HS minus for it to form H2S. This is a tricky one, so we'll put it like that. But basically, these are related to each other in the sense that water is, again, this is the base here because it doesn't have any hydrogens to give away, so it has to be the base. And 2 minus is becoming an OH minus, so it's adding an H and a plus, so this is a conjugate acid. And water here is acting as a acid again, giving its conjugate base OH minus. And here OH minus is acting as both the conjugate acid and conjugate base species because O2 minus and water are related like that. So this is the acid base. Again, conjugate acid base pairs. Here, again, let's just take a look at this carefully. NH3 is accepting an H plus. So NH3 is accepting a H plus to become NH4 plus. So that has to be the base, and NH4 plus will then be the conjugate acid. And so this has to be the acid and its conjugate base, which makes sense because this proton has now left H2S and it's left with HS minus over there. So to continue, we have a acid, because it's H2SO4, we should know that that's an acid, and water here acts as a base. We can also tell that by looking at the products, because water is clearly accepting H plus to form H3O plus, and HSO4 minus is formed when H2SO4 gives away an H plus. So plus minus, the H plus goes away, what you're left with is HSO4 minus, which is the conjugate base. Again, if you put this in water, it's going to act as a base because it has a negative charge, so we will, I don't know if the reaction's here, it's not here, but because HSO4 minus has a negative charge, it could act as a base and form back H2SO4, but that again won't happen because of Ka constraints, which we'll talk about later. We're actually going to skip to this page where we had to calculate the concentration of hydronium ions. Well, strong acid, so the concentration of H plus or H3O plus is the same as the concentration of acid, so H plus or H3O plus is 4.5 mole per liter. This is a dilution question, very similar to the one that we did, so I'm just going to do this very quickly. We have C1V1 equals C2V2. We have to find C2, which turns out to be 30 times 4.5 divided by 100. This is almost the same one we did. There's 1.35 mole per liter. And that is also the concentration of H plus, because HBr is a strong acid. So these two appear to be neutralization questions, so you have to approach this in a very similar manner to the example that I posted, the example that we did in class. Calculate hydroxide ions. So this is a strong base, so OH minus concentration is the same, 3.1 moles per liter. Again, this is a dilution question, so we do the dilution. 21 times 3.1 divided by 75. So concentration was 0.868 after dilution, and that will also be the concentration of OH minus because it is a strong base. The last two are again neutralization questions, so they're too long to go over, I think, in this video. Actually, I can maybe quickly do the answer. 0. So you would calculate number of moles of acid, number of moles of base. Here, I mean, it's asked you to calculate H plus ions, so you have to assume that the base is the limiting reagent. And this is, fortunately, a 1-to-1 ratio, so there's no confusion there. Sorry, it is a 1-to-1 ratio, so there's no problems there. You would find number of moles of acid, number of moles of base, subtract number of moles of acid, number of moles of base from number of moles of acid to get excess acid, after which you would divide by the total volume obtained by adding these two volumes to get concentration of acid, which would then be concentration of H plus or H3O plus ions because it's a strong acid. So hopefully we followed that. And these two would be performed the same way. Okay, so here it's kind of confusing because it's not given us which one's the limiting reagent explicitly in the question. We have to actually calculate that individually, but I mean, it's the same principle more or less. Here we have a magnesium oxide, and therefore we have to find number of moles of magnesium oxide by doing mass divided by molar mass of magnesium oxide. which would then create a base when added to water. Magnesium oxide is a base as well. So we can write that balanced equation and go from there. So here would be the balanced chemical equation for question number 8. And you, again, find number of moles of base, number of moles of acid, multiply that by 2, subtract from number of moles of base, and then you would be able to calculate whatever the excess, number of moles of excess. The volume is just 70 milliliters, so you find concentration, and then depending on whether it's an acid or base, you could calculate whether you had excess OH minus or H plus ions. So that's it for this week's homework, or this day's lessons homework. And if you have any questions, you can ask me or Miss McKenzie in class or leave a comment. I'll see everybody in class.